Okay, it is 6:30, and thank you everyone for coming. This is the beginning of the capstones for academic year 2021. Our graduates tonight will be presenting Bailey Wellen and Scott White and Noah Lindner. All of our graduate seniors this year faced incredibly adverse conditions, and we are presenting via Zoom. And hopefully next year we can gather together in person to celebrate somehow. Somehow we'll do it. Your achievements. With that, Bailey, would you like to take it over?
Yeah, thank you. So I'll be presenting a video and then afterwards I'll unmute myself and I can answer any questions.
Hi, my name is Bailey Wellen, and this is my senior capstone for my computer science and data science majors at Carthage College. So the question that I tried to tackle in my capstone is, can a machine learning model predict the enjoyability of a recording of Happy Birthday? So I know I have been at birthday parties in the past where everybody was singing and it doesn't always sound great in the happy birthday renditions. So my goal was to see if my program could discern whether or not a recording sounded good or if it was something that people would actually like to listen to. So the idea of enjoyability of music is pretty subjective, and so that is kind of what I tried to tackle, is how I could assess that and how I could build a model to handle that. And so this is the overview of the way that I tackled this project. So the first step was to collect the data. There aren't any databases of happy birthday recordings that I know of, so that part was on me. And then I had to collect ratings on the data to understand how enjoyable each of the recordings were. And then I had to take some time cleaning and formatting that data so that it was ready to be fed into the model. Once that was done, I was able to start thinking about what models would be best for me and considering some methods that might be helpful to improving the accuracy. Then I got to look at the results of that model and see how accurate it was, consider how frequently the model predicted each type of rating, and kind of think about musically what some reasons might be that would decrease the accuracy or what ways I could improve it. And then finally, I deployed my model to a website so that somebody could go to a website and they could upload a recording of them singing and they would get some feedback on how it sounded based on the training data. So that is where the name of this project, which is Please Don't Sing, comes in, that's the name of my website. So I'm going to go through and tell you a little bit more about each of these steps and how I tackled them and what I learned throughout. So like I said, the first step was collecting the data. So the first step of collecting the data was collecting the recordings themselves. So I did that through just a Google form, and I ended up collecting 88 recordings of Happy Birthday. So that Google form was pretty simple. Didn't take too much work or too much setting up. The next step was to collect ratings on those 88 recordings. And so I did find that people were much more willing to rate music than they were to sing themselves. So I collected 573 ratings on those 88 recordings. And the process to collect those ratings was actually a little bit more complicated than it was to collect the recordings themselves. So I'll get into how I did that. So I collected the ratings using a tool called R-Shiny. So I wrote a script using the programming language R. And there's a module called R-Shiny that is usually used to create dashboards for data visualization. But I found that it was a really good free tool where I could post my code that would usually be a dashboard, but that made it publicly available to anybody who wanted to contribute to this project. And so it was live. It actually still is live. And people could go in and they could listen to the ratings and give their feedback. So this photo on the right here is what it looked like. So I would give each rater 5 different recordings. They could press play, they could listen to it, and then they had this sliding bar where they could rate it on a scale of 1 to 10, 10 being the highest. And then what I did is I actually used the Google Sheets API in R. And so every time that somebody went through and rated their recordings and they pressed submit, I actually had my script right back to a Google Sheet that I had set up. So in order to do this, I had to spend some time learning about and researching authentication because I didn't want my volunteers or participants to have to log into their Google account. So through some research, I found that I could use a Google Service account, which would essentially do all of the transactions for the users so that they didn't have to worry about logging in themselves. So it took a good amount of time for me to research this and figure out how to get the authentication down. But in the end, it ended up working really well. So each user would be able to give their ratings and then it would write it back to a Google Sheet so that I had all the data in the same place. So looking into the output here, this is the data that I was working with right before I ended up going into my model. So this is the recordings data. So it looks a little bit overwhelming, and it was overwhelming to me as well. And what it did is each of these rows was one recording. So I had 88 rows, and each column was one frequency that I was working with. So this was just comma separated values, and the biggest problem here was that the rows were different lengths. So one recording might have been 30 seconds long and another might have been only 10. And so some of them had over 2,000 columns and others only had 800 or 700. So as I started moving towards a model or thinking about how I would build a model, I realized I would need to condense this data so that it was all the same length. So that was my biggest problem with this data, but that's what it looked like at first. And then my rating data looked like this. So I had from that our Shiny dashboard that I showed you on the last slide, I had the reviewer's name, I had the ID of the rating that they had listened to, and then I had that number that they put in on the sliding scale. So this was the raw data before I did any cleaning to it, and I knew that I was going to have to do some editing so that this data would be in a format that I could put into the model. So in order to clean it, I had to go through a couple steps. So first, for the recording data, in order to get it into the format that you just saw it in, I used a Python module called Audio. It was a really helpful module that allowed me to give it an MP3 file, and then it gave me back a list of frequencies. So that's what you saw in that last slide. And like I said, my first step was to turn it into a uniform length. So I needed them all to have the same length. I found that the average length of those was about 1,000. So I came up with an algorithm based on the confidence level of each one where it would turn them into all the same length. So that took a bit of time for me to do, but it was really interesting actually to look at that raw data and figure out how I could change it so that I could use it for the task I was trying to do. And then I spent some time working with Professor Sarah Jensen, and we were talking about the way that audio is stored digitally. And I found that I needed to turn those frequencies from hertz into the number of half steps away from some note. So I chose the tuning note, which is 440. And the reason for this is frequencies are actually stored in a way where it's not equal intervals. So the difference between 10 hertz on a lower point on the scale is different than the difference between 10 hertz higher. So I wanted to really standardize that so I knew what my input data was. And so I went through a pretty complicated formula that would turn a frequency from the number of half steps from that tuning note. Okay, so then after my recording data was normalized, I decided that I needed to clean the rating data as well. So my biggest concern there was that different raters would be either more or less generous depending on their perspective and their musical background and everything like that. And so I didn't want the randomization of the recordings to play a part in my model. And so what I did is I found the average score for each person. So that's why I needed the names in that data. And then from there, I was able to find the distance from that given rating to the average score of that rater. So this just gave me a normalized or standardized set of data that I could then know that it wasn't biased depending on the raters when I put it into the model. Okay, so now that my data was cleaned, I knew that I was ready to build my machine learning model. So this is what the data on the bottom looked like after all of that cleaning. So I had the differences from that cleaned recording data, and I had a z-score for each recording, and the z-score is what I was trying to predict. So looking at all my data, I knew that I had numerical inputs, and I was trying to predict a numerical field. And so I kind of had a feeling that I was going to be working with a regression, but at the time I didn't really know the difference between any of the types of regressions. So this was a big thing that I learned through this project. I spent a lot of time watching YouTube videos and LinkedIn learning tutorials to understand the difference between different types of regression. So I tried linear regression, logistic regression, ridge regression. I spent a little bit of time looking into a couple other ones. And I did also try one classification machine learning model, which is called naive Bayes. And essentially what I did is I tried each of these models on the data, and then I looked at what the accuracy was to decide which one might be the best. So it turned out that ridge regression was my best fit. And ridge regression also is good because it penalizes collinearity. So if any of these input features are correlated, it penalizes those coefficients so that we don't have to worry about that. So I found that ridge regression was the best choice, and that is the model that I ended up implementing. But I learned a lot about these other models just through the process of trying to pick the right one. And in addition to building that model, I spent a lot of time looking at my data both before and after so that I made sure I had a good understanding of it. And so there were a couple other methods that I used to do that. So before even building the model, I used matplotlib in Python to create some graphs so that I knew what the spread was like and kind of what the data distribution was. I also used k-fold cross-validation, which is a tool that you can use when your data set is small, so you can increase your confidence in the prediction accuracy. So I did that. And then those two graphs on there are two that I created to visualize the residuals after I did the prediction. So after the k-fold cross-validation, this is the residuals. So I was happy with this. It doesn't follow a pattern. It is centered around 0. And so I was able to use some new Python visualization libraries that could help me with understanding my data better. So those were some of the methods I used alongside building my model. So now that I had built my model, I knew that I could move on to looking at the results and looking at my prediction accuracy. So the big takeaway here was I found that my model increased prediction accuracy by 18% as compared to a randomized or a dummy model. So just to break that number, that 18% down for you a little bit more, I was predicting something that had 3 classes in the end. And so that was, it could be a good recording, it could be a bad recording, or it could be an okay recording. And I found that I had 50.57% accuracy. So it predicted the exact correct class 50% of the time. And then not only did it predict the right one 50% of the time, but 41% of the time it was only one class off. So if it was supposed to be good, it might have predicted okay, or if it was supposed to be okay, it might have predicted bad. And so that leaves only 8.2% of the time did it predict the wrong class. So only 8.2% of the time did it say it was good when it should have been bad, or bad when it should have been good. So overall, I was really happy with these numbers. They kind of showed that we were able to increase that accuracy from if we were just predicting random, which is always the goal. And as I looked at these, I was trying to think about why the numbers might not be higher. And some things that I was thinking about were our accuracy is dependent on the data that was input, and so the data that I had was really varied, and it there were instruments in some, there were different vocal ranges. Some of the people who submitted their recordings had background noise, and so I believe that probably contributed to some of the inaccuracy in the prediction. And also, just in music in general, there are a lot of factors that feed into whether something is enjoyable besides just the pure note. So things like vibrato or tone definitely matter in how enjoyable something sounds. And so I think there are some aspects to music that my model just couldn't pick up because it was only looking at frequencies. So with all of that in mind, when I look at these numbers of accuracy, I'm really happy with how my model performed. Once I had finished looking at the results, I knew that I could move on to building my website, which is the way that I was going to display all of my work. So this was definitely new to me. I don't have very much experience with front-end development, and so I had a lot to learn. So I buckled down and I started learning from LinkedIn Learning. I took a couple of courses on there to learn how to use Flask and how to do web development. It took a lot of trial and error as well, where I would change something in my HTML or my CSS, and I would implement it, and then I would run it and see how it looked and if I liked it. And so this took a lot of time for me, but it was definitely new and it was fun, and I'm glad that I had the chance to learn some front end. After I had that website built through Flask, I decided I wanted to deploy it. So I didn't want it to just run on my machine, but I wanted other people to be able to view it. And I used Heroku for that. So Heroku is a free service where I could upload my code and it would deploy it for me. So there were some challenges with that, but I spent a lot of time learning independently how to do front-end development, and I'm glad that I was able to learn that. So I wanted to just demo my website really quickly. So when you go to the website, this is the landing page that you get to. I have this home page. I have a results page, which doesn't have anything until you upload it. And then I have an about page where I just talk about why I built this and give some acknowledgements. So on this home page, the first thing you can do is choose a file to upload. So conveniently, someone actually in my training data uploaded a recording too late. So this file that I'm using here was not included in my training data. And you press upload. And it gives you this little icon. So the goal really for me was to be able to give the user a rating. And so here it gives them a numerical rating, and it also puts their score on a scale so that they can kind of visualize what that number means. So in this case, a 61.69 is okay. It's not great, but it's not bad either. And so that's what we report back to the user. So people can go through, they can upload as many as they want, and kind of see how they compare to the rest of the training data that I had. So this was kind of the front end that I envisioned, and I'm really happy with the way that this turned out. Okay, so now that I have finished that website, I just kind of spent some time reflecting on what I'd learned through this project. And the first thing I want to touch on is just why this project was important to me and why I chose it in the first place. So I am a musician. I participate in the Carthage Philharmonic here on campus, and music has been a really important part of my life for just about as long as I can remember. So as I went into my thesis and I thought about what I wanted to tackle, I really felt like I wanted to find a way to combine my interests in music and in computer science and data science. And so I spent some time brainstorming on this, and along with Professor Kowalowicz's help, found this way that it was kind of a fun, silly project, but it was still a way that I could combine my interests and find a way to research both of them at the same time. So I had a lot of fun with this project. I really enjoyed the time that I spent on it and everything that I learned through it. So what I learned through this project is, first and foremost, I solidified my interest in machine learning. I knew before that I really enjoyed the cross-section of statistics and computing, but through this project I really found that the parts where I was building the model and I was messing with the data and looking at the accuracy were really the parts that I loved. And so I'm walking away from this knowing that I want to pursue projects and work in the future where I can continue to learn about machine learning. I also learned a lot about expectations for model accuracy and how to manage those expectations. I came into the project thinking that I might achieve 90 or 95 or 98% model accuracy when I was predicting this data about music. And as I went through it, I realized that that just wasn't realistic in the context of the data that I was working with. So I think I learned a lot about how model accuracy really depends on what type of data you're working with, and how it's okay to not be achieving those high numbers, and how a high number is actually subjective to what the data is. And finally, as I've been saying, I learned a lot about front-end development. This was my first time doing something like this, and so I really enjoyed learning about that. So I've already touched on most of these, but I just wanted to really highlight the technical skills that I've developed throughout this project. So from R to Python to HTML and CSS, I feel like I've learned a lot of technical skills that I'm going to be able to walk away with and apply to my future work or to personal projects. So thank you all for listening, and thank you also to all of the Carthage professors and all of the other students in the computer science department. I know I couldn't have done this without all of their help, and I'm also just grateful for the past 4 years, for everything that I've learned from the professors and for all the time that I've gotten to spend with the other computer science majors. I've learned a lot and I've really enjoyed the experience. So thank you so much.
Thank you. I can answer any questions that anybody has.
Hi, Bailey. This is Professor Mahoney. It was an excellent presentation. Thank you. I had a question about the algorithm you use to make the samples the same length. And I'm wondering if you could maybe just spend a little bit of time talking about that. My initial thoughts was maybe, do you find the shortest one and then you adjust all the longer ones to be shorter, or do you do the opposite? Did you find the longest sample and stretch out the short ones? How did you go about making them the same?
Yeah, that's a good question. So I had considered making them all the length of the shortest one or the other way, like you had mentioned. But there were a couple that were really different from all the rest. So some people sang happy birthday ridiculously quickly. And so I felt like if I shrunk it down to that size, I would be losing a lot of data. Conveniently, Audio, the package that I used, gives you the frequency and a confidence in that frequency. And so I assume that their algorithm has something to do with background noise or how sure they are in that number. And so what I did is I found that the average length was about 1,000. And so any of them that were shorter than 1,000, I took the ones that were the most confident, the frequencies that the program was the most confident in, and I duplicated them right next to where they occurred. So it still kept the general shape of the frequencies from the original array, but it just made it kind of stretched out in the places where it was the most confident. And then I did the opposite on the ones that were too long. So if it was over 1,000, I went through and I found the ones that had the lowest confidence and I dropped them until I had a length of 1,000.
Interesting. Yeah, cool. Thank you.
What would you say generally is your overall enjoyability of the song Happy Birthday after doing this project?
Not very high, to be honest. I went through it and some of them were in different file formats. And so the module I wanted to use needed an MP3. And so I had to listen to many of them in order to put it through the file, like the program I used to convert to MP3. So I've heard it a lot of times.
Hi, Bailey. Great job. By any chance, were any of the, excuse me, audio files that were submitted from a known great singer? And I was wondering what was their rating that they achieved?
We did have some musicians submit. I didn't run them through on my model because since my sample size was so low, I used all 88 to train the model. So I didn't think that would be a fair thing to put one through that had already been used in the training data. But that would be a good thing to test if I could get somebody to record again on something that isn't already included. That's a good idea.
I think Professor Bingen will volunteer to be your excellent singer.
Yeah, I'll ask my wife.
Okay, folks, some more questions for Bailey?
Could the model you used be used for like a live stream of audio to give live feedback to someone on what the predicted enjoyability of their singing is in close to real time, or is it really only going to work on pre-recorded material?
You could record it right then and then submit it, and that would be the closest thing to real time that my current website would do. I wasn't able to implement something where you could record it on the website, but I think that would be a good thing to do in the future.
Okay, everybody, let's give Bailey a round of applause, either by icon or emoji or by actual hands. Outstanding, Bailey. I'm very, very pleased. You've accomplished great things in your years here, and I hope you keep in touch to learn so we can learn about the great things you do in the future. Congratulations.
Thank you.